Welcome back to Fun with Data with Marcel-Jan, that's me. And today we're going to look at asteroid data again, but this time we're going to work with MongoDB. So what is MongoDB? Well, MongoDB is a NoSQL database. And what does that mean? Well, to be honest, before I didn't really know. But to learn more, I went to classcentral.com and looked for MongoDB courses. And at a certain point I found a very nice basics course from MongoDB University, and it's actually free, and it's only 3 weeks with a certificate and everything. So what's not to like? It only takes something like 2-3 hours a week, so it's not too hard. It won't take too much of your time. So here I am in MongoDB's Compass tool, and you'll have see in a moment what that does. I log in, and here you have all kinds of databases. So that's a familiar term. And in these databases, you have so-called collections. So collections are a bit of sort of comparable with tables in relational databases. And in these collections, there are documents which are sort of relatable to rows in relational database in tables there. Except that in NoSQL databases, you can have some documents contain a nested information where others don't. They can have some fields where others don't. And here you see how it looks when you analyze that data, because MongoDB Compass has a very nice feature. You can have a look at Schema, but they basically show you an overview of the data that you have. So you can click on, for example, all animations, short animations in a movie database. And now you get to see an overview of the data of just that set of genres. And as you can see, now we only have 15,000 documents left of 1 million. And so you can click on that. You can look at which are the largest amounts of languages. You can have, and you have a sample of what's in the strings, and you can reload that. You can see other plots in this case. This was all running on a cloud database, a database in the cloud. MongoDB has something called Atlas. And you can actually run this for free. You don't even need your credit card. That's another plus. But how to connect? Because I wanted to upload my asteroid data. And you use a tool for that called Mongo Import. But I was struggling with the connect string for that. But turns out there's just a page on the site where you can just copy example code. But unfortunately, it didn't work. I tried to import my JSON data, my JSON file with just 10k asteroids, but it turns out you have to do something a little bit extra. You need to encapsulate your JSON. So that is what I'm basically doing here. In MongoDB terms, what I basically do is I make a lot of documents within one large document called asteroids. And now we go to the end of the document and close it off with another curly bracket and give it another try. And now I do upload this data. It actually works. So let's have a look. Let's analyze that data. And this sometimes takes a little while, but there you have it. So there are the asteroids. So there you see that this is nested. So all my data is basically nested in one document called asteroids. And here I can see all the data that's in that JSON file. So here is the eccentricity of the orbit, of the asteroid's orbits. And you can see inclination here, for example. There's something like, I think this is something like a magnitude or reflectivity. And here you also see example names of asteroids. It's just a sample of the whole set. Okay, 10,000 asteroids, that's nice, but the actual set has much more. And now, so this is what I'm trying here. I'm trying to upload the whole set, 750,000 asteroids. I downloaded it last week, and we try, and it seems to work until at one point it actually doesn't work. So what I had to do, I will put the sample code that I used to do this on my blog. I had to do a JSON array, and this time I had to use the data unencapsulated, so the original file basically. So that's nice. It takes a while, but at some point you actually see, yes, we uploaded the data. Here are, as you can see, 755,189 documents or asteroids. And this time these are not encapsulated, so they're not documents within documents. I just can look at the fields right away. And what I can do is I can look at that data, and here is the semi-major axis, which is a measure of an average size of the orbit of the asteroid. And what I can do is I can look at all the asteroids in the asteroid belt, roughly between semi-major axis greater than 2 astronomical units and less than or equal to 3.5 astronomical units. So there we are, and we again get an overview of that data, but as you can see, it's still quite a lot. But so in case of the asteroid belt, let's have a look at the Kuiper belt, which is outside the orbit of Neptune. So in this time we're going to look at a semi-major axis larger than 30 astronomical units. Just eyeballing the Kuiper belt, start of the Kuiper belt here. And this is analyzing quite quickly actually, and there you have it. These are all orbits of Kuiper belt objects. And you can see we have only 2,485 documents. And let's have a look at the inclination, because some of the Kuiper belt objects, their orbit is a little bit turned, possibly because of 1 or 2 planets we haven't found outside the Kuiper belt yet. One of them is the hypothetical planet 9, found by Mike Brown and Konstantin Batygin. And now you see that now you can have a look at, for example, the eccentricity. So you can also see that the orbits of the Kuiper belt objects here are much more eccentric. And here's the inclination. And you also see that from the subset that we chose, we again get a graph of how the inclination is of this set. And you get a sample of names of Kuiper belt objects. We see Pluto, Orcus, and Haumea. And these are the larger ones. Some others that I don't know. And yeah, so this is working pretty well. And yeah, so that basically looks pretty well for first touch with MongoDB. Thank you for watching. I'm Marcel-Jan, and this is my blog where I'll put in the sample code. This is my Twitter account. And this is where I work, Open Circle Solutions in Eindhoven. Thank you for watching.